Hello, hi everyone, good afternoon and welcome to our channel. So here today we are going to learn about sign convention and lens equation. So there is a continuation of the series that we had started, the Pioneer series for grade 10. So we are going to continue from here, okay. So if you are seeing me for the first time, my name is Dr. Akash. I have a PhD in physics from National University of Singapore. This is like one of the top university in the world, ranked in top 10 in the world. I have a BSM's dual degree from ISA Pune as ranker in JEE Advanced, and like I have 7 years of teaching experience. Alright, so let's start with our today's topic, that is sign convention. So what is sign convention? So if you have a lens, so we have learned there are two types of lens. It can be either convex lens or it can be a concave lens, right? So now this is the optical center. There is a point O, that is the optical center. So we consider that as our center of the lens. So now we have learned this is the y-axis and this is the x-axis. So now place the lens such that this origin is our optical center. So optical center will be placed at the origin and this lens is placed along the y-axis. So something like this. So this is how you need to place the lens, right? So now this side, if you go, so all the distances along the x-axis you measure from this optical center. If you go towards the right, there is a right side. If you go towards right, this is a positive, and if you go towards the left, then this would be negative. So all the distances, what do you measure along the x-axis? It can be u, v and f. U, v and f. U is the object distance, v is the image distance, f is the focal length. So these distances you measure along the x-axis. And what do you measure along y-axis? Along the y-axis, if you go here up is positive and down, so down would be negative. So if you measure the distances above the principal axis, so that is generally if you place an object something like this, object is above the principal axis, so the height, you measure the height either up or down, so that height you measure along the y-axis. Clear? So that is the sign convention. There are two more things here. All the distances, they are measured from the optical center. Then object is always kept left of the lens. So we always keep an object on the left side. Hi Shahida, good afternoon. So again, here we have a concave lens. Now this is the direction of the incident ray. There is our object, there is an object. So this distance of the object from the optical center, this will become object distance. So let's suppose for this lens, let's suppose the image is formed somewhere here. If this is the image, so this would be the image distance. This height would be height of the object, this height would be height of the image. So this is how we figure out the sign convention. Clear? So when you go to the left from the origin or from the optical center, if you move towards the left, distances are negative. If you go towards right, distances are going to be positive. Now same for the convex lens. There is an optical center, go to the right, distances would be positive, come to the left, it is a negative distance. If you go up, above, distances are positive, below, distances are negative. Same for both the lenses. Just make sure that this origin is same as the optical center. Clear? Now the focal length, how the focal length is defined. Let's suppose if you have a convex lens, these are the incident rays. When they fall onto the convex lens, they converge at this point. There is a focus, right? So this is the here optical center, this is the focal length. So focal length, you are going towards right, so the focal length would be positive in this case. For the concave lens, these are the incident rays. When they fall onto the concave lens, they diverge. That means they go away from each other. So they appear to come from this point. There is the optical center here, and this point here is the focus. So we measure the focal length towards left. So there is a focal length measured towards the left. So focal length here is going to be negative. So this is the negative focal length, right? So focal length of a convex lens is positive and focal length of a concave lens is negative. Clear? Now this equation is called as lens equation. These are very similar to the mirror equation, just that there is a minus sign. That is very crucial. So 1 by V, what is V? V is the image distance, minus 1 by U, U is the object distance, and F is the focal length. So to use this equation correctly, if you want to use this equation correctly, you have to use a proper sign convention. If your sign convention is correct, then only you can use this equation, otherwise you cannot use the equation. Okay. Now there is a question. I'll write down the lens equation here. 1 by V minus 1 by U is 1 by F. We have to use this lens equation to solve this problem. Try to solve. I'll read the question for you. Convex lens of focal length 16 centimeter. It forms a virtual image double the size of object. It forms a virtual image double the size of object. The distance between object from the lens is. So now we have a convex lens. We have a convex lens. Let's suppose there is a convex lens, and here we get a virtual image. It is a virtual image. So when do we get a virtual image? There is an optical center. There is our F1, 2F1, there is F2 and 2F2. So object should be placed between F1 and O. So this is the object. So for this object, the image is virtual. Virtual image means behind the lens. So somewhere in this range, and it is given double the size. So this is the image. Now I am going to show you something. You can look at these two triangles. If you join this with here and if you join this with the origin, so this is the object distance U, this is the image distance V, this is the height of the image, object, height of the image. Now these two triangles, they are similar triangles. So when you have similar triangles, there is a property, the sides, they are in the equivalent ratio. So for example, you can write height of the image divided by height of the object should be equal to this V. V is the image distance divided by U. Okay. And there is one more thing. This is nothing but the magnification. This is called as magnification of the lens. So now together with this equation, we have to use this equation to solve this question. So how will you solve? So it is given that the image is double the size. So that means magnification is 2 times. Height of the image is 2 times the height of the object. So this ratio is 2. So that means this ratio is 2. If this ratio is 2, you can write V is equal to 2 times U. Now we have to find out the distance of the object. How will you find out? We have this equation, right? Substitute V is equal to 2U in this equation. So here we have 1 divided by 2U minus 1 by U. This is equal to 1 by F. But what is the focal length? Focal length is 16 centimeter. How much is the focal length? It is 16 centimeter. This is a convex lens, so focal length is positive. So it is 1 by 16. This is a plus 16. Now simplify. So there is 1 minus 2, which is minus 1 by U, is 1 by 16. So from here U is minus 16 centimeter. So what is the object distance? Object distance from the lens is 16 centimeter. That is the right answer. Clear everyone? Very easy, very normal concept, very simple, easy to understand. Just remember, whenever you want to use this equation, this is called as lens equation. So if you want to use the lens equation, you have to use a proper sign convention. Otherwise, you cannot use this formula. Alright, so that's it for today. Thank you so much. This is our Telegram channel. You'll get all the updates, all these notes, questions, everything on this Telegram channel. So do follow us, like us. Bye bye, take care. See you again in the next class. End करो.